Hello everyone, Suhail this side. Welcome back to our channel. This is episode 2 in the Kafka Zero to Hero series. In this video, we'll discuss about Kafka fundamentals. In the last video, we concluded that Kafka is a distributed event streaming platform. Now, there could be multiple applications connecting to the Kafka, right? For example, in the picture shown here, the application 1 could be acting as a producer or a consumer, or the application 2 can also act like a producer and a consumer, and they both are talking to Kafka. But in real life, we don't have a single Kafka server. We have multiple Kafka servers and they are running together. So we call that as a cluster. So that is known as Kafka cluster. Now, when we have Kafka cluster, so we need something to manage this cluster, that what all the servers are up and running in this particular cluster, because it could have thousands of Kafka servers, right? So most of the websites talk about Zookeeper. Zookeeper was mandatory to run along with Kafka with the earlier versions, but with the new versions of the Kafka, it is no more mandatory to run Zookeeper. But since most of the companies are still using Zookeeper, so let's discuss Zookeeper in brief so that you can get a fair idea about Zookeeper as well. So Zookeeper was acting like a manager for Kafka. So I already mentioned that in new versions, Zookeeper has been ruled out, and instead of Zookeeper, what we have? We have KRaft. Now let's discuss Zookeeper. So Zookeeper is a distributed coordination service, right? What it provides, it does the cluster management. Cluster management means which of the Kafka server is up and running, right? So that request or event or message should be sent to the server which is up and running, right? And later it would be replicated to the down servers when they come up, right? So what other functionalities it provides? It does the ladder action. For example, in the databases we have master and some replicas. Similar concept here, that out of few in this cluster, some of the servers would be acting as a leader and some of the servers would be acting as a replicas. So similar concept here, but which of the node would be leader? That has to be that decision has to be made. Who will do that? The Zookeeper do that, right? And Zookeeper also store the configuration management, that Kafka server's IP address, port number, what are the replicas for a particular server, topics, configurations, which we will discuss in the upcoming sessions and also in this video. But as of now, you can just imagine it stores the configuration. Now, what were the challenges with the Zookeeper? Why Zookeeper is deprecated? Let's discuss that points. So earlier what was happening, like there is a Kafka cluster which we need to maintain, right? Now to manage this cluster we need Zookeeper. So Zookeeper has to be maintained in a separate cluster. So first point is the infrastructure cost got increased, right? Because we need separate VMs to manage the Zookeeper. So infrastructure cost involved, right? Second point is the operational complexity. So you need to maintain, you need to have people who have fair understanding of Zookeeper as well, right? And also the scalability issues. For example, if the Kafka cluster grows, so your Zookeeper may become bottleneck. Why? Because you have to ensure that Zookeeper must remain highly available. Otherwise, there is no one to manage this Kafka cluster. No one knows which of the server is up and running. Request can be routed to any of the server which are down as well, right? So you would get timeout and other stuff, right? So you need something to manage this cluster. So Zookeeper was doing that. So these were the challenges with the Zookeeper. Now let's move further. Before discussing topics and Kafka fundamentals, let's discuss the basic things. What are the basic things? So let's discuss first what is an event. So event is anything that happened. For example, on Facebook, I like a post. So that could be a post event. For example, on Amazon, I place an order. That would be an order event. So in Kafka, we call that event as record or message, right? So these are the Kafka terminologies. You can say that in Kafka we call that records or messages, right? Okay. Now if we give event to Kafka, for example, this is the Kafka cluster. If we give events to it, right, there is stream of events passing to the Kafka cluster. How does it store and where does it store? So Kafka has something called topic inside the server, all the servers. So in, for example, in, let's consider, take one server, and Kafka server would contain topic in which they would store the data. So topic is nothing but a way of collecting and organizing the data within a cluster. That is simple, right? So let's move further. Let's discuss more about topic. To visualize more, you can imagine that topic is just a similar to table in your relational database. For example, in table, you insert some row, so your data gets stored in the table. Similar to that, you can visualize that topic is in Kafka. So you push an event, and the event gets stored in a topic, right? Now you might be asking, okay, in database table, in database we can have n number of tables. Very similarly here, how many topics we can have here? You can have n number of topics. For example, user clicks, likes event, order event. There could be n number of topics you can create depending on the use case and depending on the your business model, right? Now, let's see the flow first. For example, let's take an example of e-commerce, that order service, and out of Kafka cluster, let's consider single server. That is Kafka server. So in a cluster, there could be thousands of servers. You can just imagine, out of thousand, we have considered one server here. So in Kafka server, we have the topic, right? And for example, let's say this is the notification service. Now, on e-commerce site, I place an order, so that event, where it goes to the Kafka server. On Kafka server, where it would be stored, it would be stored on topic. Now there could be other services as well. For example, when I place an order, I usually get email or SMS. So there could be notification service at other end which would receive the same event from this Kafka server, from where it would get, from the topic, right? And notification service would then send the notification to the user. Now your question could be like, what will happen if this Kafka server is down? So as I already mentioned, we will not be running single Kafka instance. So there would be multiple Kafka servers running in a cluster. So in Kafka, we say server is equal to broker. So Kafka, if you hear in the organization, you will hear terms like this, broker, right? So it is nothing that the same Kafka server is equal to Kafka broker in the Kafka terminology. So that is the simple thing, right? So as we discussed, the Zookeeper has been deprecated, right? From, and we will discuss with the KRaft. We will also do the playground, Kafka playground, with the KRaft only. Now why I choose KRaft? Because now sooner or later in your organization you might get work to upgrade Kafka with the KRaft. So it would be helpful there, because Zookeeper is anyway going to be deprecated. So that is the reason I choose KRaft. So let's discuss what is KRaft. Now, as we discussed with the KRaft, there is no mandatory to run Zookeeper. Now let's discuss the same scenario again. Order service is there, and we have Kafka cluster, and we have so many Kafka servers present here. As I already mentioned, the Kafka server is equal to broker. That is clear. Now in KRaft, what happens? It means one of this broker, out of, for example, here 6 brokers are there, one of the Kafka broker would be acting like a manager, right? For example, this one acting like a manager. So this manager will assign responsibility to the brokers, right? What kind of responsibility? We will discuss, for example, that this topic is for this broker only, right? So these are the kind of responsibilities that, so we usually call this we usually call this broker, right, who is selected as a manager, we'll call this broker as a controller, right? So in Kafka terminology we call that as a controller. We'll see in Kafka setup as well, all the configuration, there you will see that this broker is configured like a controller, this broker is configured like a normal broker. So we'll see all this. Now your next question could be, what if this particular controller dies, right? This could be another question. Actually, this in this cluster, they all work like a family, right? So if this controller dies, some one of the other brokers would become a controller, right? So that's how things work. Now let's see the flow. For example, we fire a topic create command. This is the topic which we would create. For example, as I already mentioned that, for example, the order event, or we place an order, it would be stored in a topic. Which topic? In orders event topic. For example, in database, before inserting any data, right, you need to create table, right? So similar concept here. Before publishing any event to the Kafka, you need to create topic. So that is what we are discussing here, right? So for example, I fire a command for topic create, that is the order event. Now what would happen? As we discussed, the first thing, it would go to the controller, because broker don't have any idea on where, on which broker this topic would be created, or which broker would held all the messages for this particular topic. So what would be the flow? The request would be going to the controller. Now controller will assign this topic to one of the broker, right? For example, this broker he has selected, right? So then what would happen? Now event would come, event would be stored in this topic. Now how? Because it already knows, okay, that this assigned broker will keep the event safe in its machine. Who decide this is the broker which will save the event? The controller decides at the time of topic create command, because those are the commands which would firstly go to the controller, and then controller says, okay, that it maintains the metadata, that this topic would be associated with this broker, this topic would be associated with this broker. So it has all the metadata, right? So as and when the event gets fired, the assigned broker will get the event. So right, so that's how it is. Now your second question might be, okay, now we have, the controller had decided the broker. Now what if this broker dies, right? Now in real life, things work like, the controller will identify couple of more nodes to be backup. How? Because when we say the topic create command, we usually mention the replication factor as well, which we will discuss in the Kafka playground, and also we'll discuss the Kafka topic create command at the end of this lecture. But when we fire the Kafka create command, topic create command, we provide replication factor as well. There we provide, for example, the replication factor 2. So let's see the flow again now. What would happen if we pass the replication factor 2? So now what would happen? The event would be fired. Where it would be stored? It would be stored in the topics orders event topic, right? Now in this case, assigned broker will receive the event, that we already discussed. Now this assigned broker will also send the event to the replicas, right? The replicas, which replicas? The two replicas which we have already mentioned in the create command. Now your question could be, who will select these replicas? The controller will select the replicas, because when we create the topic create command, so at that point of time, controller will find out the nodes. For example, there are 6 nodes, so there could be one primary and 2 replicas, right? Controller will decide that this broker is the primary broker for this particular topic, and these 2 brokers would be the replicas for the topic. So controller has all the authority to decide which broker is assigned which topic, and it also maintains the metadata, and also all the brokers maintains the metadata. Controller, once it has the metadata, it would pass all the metadata information to all the brokers. That's how actually it works. Now your next question could be, okay, now if primary broker dies, what would happen? Now one of the replicas would become primary, because now we have three brokers, right? Master and two replicas, primary and two replicas, right? Now one of the replicas would become primary. Now for example, let's see, in this case we have six brokers, right? Just one thing to note, that one broker can have multiple topics. For example, this broker has order event topic as well as notification topic, right? Similarly, this broker have order event topic and notification topic. So one broker can have multiple topics. Now one broker can be primary for order event topic, and one broker could be primary for notification event topic. But there could be other case as well. The same broker could be primary for order event, or the same broker could be primary for notification event. So usually, basically the point is data is distributed across the cluster. For example, in this case, this has two topics, this has two topics, this has one topic, this has two topics. So across all the nodes, the data gets distributed. Now in organization, you might have heard terms like leader, follower. So in Kafka, there is a terminology for leaders as well as followers. So in Kafka, the primary broker, we call that as a leader, and the replicas, we call that as a follower. It's as simple, right? So that's how the terminologies is. Now your next question could be, okay, now we have Kafka cluster and there are six brokers running in this, right, cluster. Now if we have Kafka cluster with thousands of machines, how can I talk to a specific broker? For example, if I have to talk to this broker, right, how would I talk to this broker? For example, in case of stateless application, there is order service instances. For example, we have 1,000 order service instances. What actually happen? Do client knows all the IP address of this 1,000 service order service? No. What is the flow? Actually, we place load balancer in front of all these instances, and client has to know the load balancer IP only, right? And then the request would be routed to any of the order service. That's how in usually things work in a stateless application. But in this case, since Kafka is a stateful application, how the client would connect to this cluster with the particular specific broker? So let's see how it is. Now, as I already mentioned, the brokers in this cluster, they work like a family. They all know about each other, right? So as I already mentioned, that all the brokers have all the metadata, right? Controller, as and when it updates the metadata, it just pushes the updates to all the brokers. So at the end, you just need to connect to one of the single server, right? So that you, if you connect to single server, you would get all the metadata information, that which topic is for which broker, right? Everything you will get. What are the replicas for this topic? All the metadata information gets stored on each and every server. It doesn't matter whether you have 1,000 brokers, 2,000 brokers, doesn't matter. As soon as you connect to the single server, it knows, okay, which broker is assigned, for example, the order event topic, right? Now let's move further. No, but still, the application still needs to know the IP address of that single server. But how? That is why we have the bootstrap server, right? So what Kafka guys has done, they have exposed the property called the bootstrap servers. As and when you are connecting to the cluster, you have to mention this property, right? So okay, you identified that this is the server where we would connect. You for example, you got the IP address of single server. No, next question is, what if that single server goes down, right? So usually what happens, you identify few of the servers from the cluster to be identified as bootstrap servers. It doesn't like for example, out of 1,000 servers, you identified, okay, 10, these are the 10 servers which would, out of which 10 servers, one would always be up and running. There is no way that all the 10 would go down at the same time. So that is how you mitigate this case, right? Now, note, few points to note. A Kafka cluster can have n servers, and servers are brokers. We already discussed. A set of servers can act like a bootstrap servers to provide initial metadata. Just to remember, the bootstrap server, right? The that property. It is not a role. It is not a controller. It is not broker. It is something for a client to make an initial connection actually. Okay. Now let's move further. This is the simple Kafka topics command. That Kafka topics, we provide the bootstrap server, for example, to which cluster we need to connect, and this is the topic. So almost this bootstrap server is mandatory in almost every command. Not almost, it is mandatory in every Kafka command. Or also if you have application which is connecting to the Kafka, you would see the bootstrap server there. Why? Because you need something to make an initial connection to the Kafka. And the topic also, in most of the commands you need to mention the topic, because usually you send the event to this particular topic, or usually you get the event from this particular topic. So this is a create command, and this is the topic name. Now let's discuss how applications connect to this Kafka cluster. So almost in every language we have Kafka client library. For example, this is order service. There is, in this code base only, the Kafka client library is included. And what it does, it just publishes the message onto the Kafka, and then Kafka stores the messages on in a topic which we already discussed. And there, at the other end, there could be notification service, and there also it has the Kafka client library included. Here it, the library in order service, the library would act as a producer. It will produce the messages, produce the events, produce the records to the Kafka. But at the notification service, it would be acting like a consumer. So generally the consumer we called as a worker as well, right, which would receive messages from the Kafka. So here the Kafka client library, we would be using the consumer kind of functionality. So that's all from my side. Thanks a lot. Please let me know your thoughts in the comment section, how you are liking, and please comment, and see you next video. Thanks a lot.